All right. So we are live right now. Welcome back. All right. I welcome all of you to this amazing platform of Tutee Learning. So in today's class, this will be the last class on differential equation where we're going to discuss about the exact differential equation, and after that we're going to start discussing about the solution of some of the previous year JEE Mains problems on the topic of differential equation, right? So today's class is going to be little bit interactive in terms that I'll be asking you some questions, and whoever answers the question first will definitely have some prizes. All right. So that's the interesting part of today's lecture. Okay. So if you are quick enough to give me the answer to the questions, I think you can definitely win some prizes. Okay. But before we start, let me ask you. So as of the last session, I asked all of you to solve the questions on orthogonal trajectory, right? So in our last class, we discuss about how to find the orthogonal trajectory for a given family of curves, right? So I gave you three homework problems to practice. I hope you have all practiced these questions, and then only you are coming for this particular class itself, right? So these are the three problems, very simple problems, right? So what did we actually understand in orthogonal trajectories? That when we have a differential equation for a particular family of curve, now if I replace that differential equation in place of derivative with respect to x for the unknown variable y, if I replace that with my negative times dx by dy, and solving that particular differential equation will yield me the solution for the orthogonal trajectory, right? So the basic idea was to replace the derivative dx by dy with negative times of dx upon dy, right? So that was the basic thing that we already learned in our last class, right? All right. I hope this idea was clear to all of you. So with this, and you must have tried to solve these problems. So anyone, any answers? Any answer to these homework problems? Any answer to these homework problems? Please let me know in the live chat. All right. So let's proceed. And meanwhile, you can let me know if you get any answers. Okay. So let us proceed today with discussion about the exact differential equation. But before I start, another quick announcement is that we have already started our online one-to-one live batches, right? So if you want to get enrolled for that particular classes and you want to study or want to get mentorship, or you still have any questions, any doubts, you can always call or WhatsApp us on this particular number. Okay. So please call and WhatsApp us on this particular number so as to get any of your queries cleared. All right. So with this part, let's get started with our discussion on exact differential equation. All right. So if I discuss about exact differential equation, well, by the word exact differential equation, so if I have a, now first and foremost thing that you need to understand from here is that whenever I have a differential equation, let us say I have a differential equation which is of the form m dy, or let us say I have a differential equation of the form where m is both function of x and y into dx plus some function of x and y that is given in terms of n, and dy is equal to 0. So let us say this is my general differential equation which is mentioned over here, right? So I have a differential equation or differential form of equation over here, right? Now this differential equation is said to be an exact differential equation. This differential equation is said to be an exact differential equation. This particular differential equation is said to be an exact differential equation of some function u. Let us say that particular function is some another function of x comma y, right? Now I have some form of differential equation. Now this particular differential equation is basically called some exact differential of a function u if and only if if and only if I am able to replace this du with some m times of dx plus some n times of dy, right? So what do we actually mean by this particular thing? I will try to explain. So please try to understand. Here u is a function of both x and y. So unlike the previous understanding that we have on function, where we have already seen that the function was dependent on only one particular variable, right? But here in this case, if I have a function which is dependent upon two variables x and y, then in order to represent the change of u with respect to sum of the quantity will be represented as the sum of change of u with respect to x multiplied the small change in x plus the rate of change of u with respect to y into multiplied with the small change in y. So if I just add that part, then I'm going to get the derivative or differential of u, or what is the change in u, right? Now then this particular differential equation, if I solve the equation, the solution of this differential equation will be obtained something like some function of u is equals to some constant. Some function of u is equals to constant. So where c is any arbitrary constant, this is the solution of that particular differential equation, right? Now to understand that it has to be a different exact differential equation, certain condition needs to be fulfilled, right? But there is one question, that how do we confirm that whether the above mentioned equation is exact or not exact, right? The answer to this question is by this following theorem. So there is one theorem which talks about, to understand whether I have a given differential equation is an exact differential equation or not. So again, let me take this particular reference. So if I have differential equation like m times of dA and n times of dy is equal to 0, let us say this is our differential equation. Now this particular differential equation is an exact differential equation if and only if now this particular thing, differential equation, is an exact differential equation. Please try to understand that it is an exact differential equation if and only if. This IFF stands for if and only if this following condition is satisfied, that is the partial derivative of m with respect to y should be equals to the partial derivative of n with respect to x. I hope this particular condition is clear. So if this particular condition is met, then only the following differential equation is basically of the form of exact differential equation, right? Now the proof of this theorem is beyond the scope of this particular discussion for JEE level, but if you are really interested, I can cite some of the references for consulting. Okay, so you can consult those references to get an understanding that how you can prove this particular thing over here. It is quite a simple proof, right? Maybe also you can try to find some literature where you can get some proof of this particular theorem, right? Now once this particular I have a exact differential equation, once I confirm that the given differential equation is of the form of exact differential equation, the solution of such differential equation is very simple. The solution of such differential equation is very simple, and it is given as the solution of such differential equation is simply given as so integration keeping y as constant. So first of all, integrate the expression, that is m times dx, keeping the y as constant, because m is both function of x and y. So you have to keep y as constant and integrate this particular term, the first term, plus the terms of y plus terms of n not containing x. Okay, so you have to take those particular terms of n that do not contain the variable x, right? So the solution is very simple. It is the integration of m dx keeping y as constant plus integration of those terms of n which do not contain x. Now I will give you some example to understand this particular thing in detail, and this will be respected with y, and that should be equal to some constant c. So this is going to be the simple solution or the general solution of such exact differential equation, right? So once I am confirmed that the given differential equation is an exact differential equation, then I can achieve the solution of such differential equation by doing this particular result. Okay, again I am saying that, and please note this is provided only with this particular condition. Okay, so please note this particular condition should be met over here, right? Otherwise the solution won't be valid, right? Is this particular part clear to all of you? Is this part clear? Vedans Gupta, good evening. Is this part clear to all of you? Do you still have any questions, any queries? Any questions? Please note down this solution. Okay, so if I have any given differential equation which is of the following form, and then I can see that the equation or the differential equation is an exact differential equation, the solution of such differential equation is fairly simple. Okay, so please note this particular thing so that we can proceed with discussion about the some of the previous year problems. Okay, so please note this particular problem. So I hope you have taken down this particular form so that we can start to discuss about the question. Okay, so let me take some simple examples to illustrate what is basically and how you are going to check. First of all, is an exact differential equation or not, and then how you are going to proceed with the solution, right? So let me take a simple example. So the first example where you have to solve for the given differential equation given as x square minus ay times the dx plus y square minus ax times dy is equal to 0. Alright, so this is the following differential equation we have over here. Now once I have this differential equation, again to check for whether it is an exact differential equation, so the steps are very simple. So I am proceeding with the solution so that you can understand. To check for, so first and foremost thing that I will do over here is that I will try to check whether it is an exact differential equation or not. Now please recall that I have represented this particular term as m and this particular term as n, right? Now I have to partially integrate or differentiate m with respect to y, and that should be equal to the partial derivative of n with respect to x. Now if this condition is fulfilled, then only I can say that my following differential equation is an exact differential equation. Alright, so if this particular condition is met, then only I can say that my following differential equation is an exact differential equation, right? So once I have this, so let me check for it. So if I partially differentiate m with respect to y, I'm going to get the real result as minus of a. Similarly, if I differentiate n partially with respect to x, then also I'm going to get the result as minus of a. So what I can see that this particular condition is met. This particular condition is met. Therefore, the following differential equation is an exact differential equation. Now, the solution of such exact differential equation is fairly simple. The general solution of such differential equation is given as integration of m dx keeping y as constant, integration of m dx keeping y as constant, plus integration of n not containing x. Okay, so those particular terms of n not containing x, and then with respect to dy, and that should be equal to some constant c, right? So this is something that you have to integrate to find to the given results, right? So if I recall, so m is basically, so integration, so my m is basically x square minus ay, so this will be x square minus ay times dx plus, now if I look carefully in n, in the expression of n, the terms which is not containing x is only y square. So I will keep over y square over here, y square only over here dy, that should be equal to some constant c. And if I just integrate this result, then this particular result is going to look like this. Alright, so this is going to be the general solution of such differential equation. I hope this is clear to all of you. Alright, is this part clear to all of you? Is this part clear? Is this part clear to all of you? Please let me know in the live chat. Sonic Groove, is this part clear? Any questions? Any questions, any queries, any issues? Please don't be afraid to ask questions, okay? Asking for question is quite a good habit to, and it shows that you have an interest to learn. Alright, so please note this is how we shall proceed for the solutions, okay? So I hope this particular understanding is clear to all of you. Now if these results are clear, then we can start to discuss about some more problems, right? So please try to solve this one as a problem, okay? So I hope this understanding is clear. Then try to solve this problem over here. Alright, try to solve this problem. Try to solve this problem. So the question says that I have 2x into log of y into dx plus x square upon y plus 3y square times of dy is equal to 0. So I have the following differential equation as like this. Please try to get to the solution of differential equation. First of all, check whether this differential equation is an exact differential equation or not. Okay, so please check that whether this differential equation is an exact differential equation or not. Alright, please try to solve this problem. 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 Alright, so let's try to see whether this particular differential equation is an exact differential equation or not. So in order to check whether this differential equation is an exact differential equation or not, what I need to do is that, now please recall that this particular term is the m term and this particular term is the nth term, right? So if I have to check for the exact differential equation, partially differentiate m with respect to y, and that should be equal to the partial differentiation of n with respect to x. Now if this particular condition is met, then only I can comment that the following differential equation is an exact differential equation, right? So if I do that, so over here if I do that, the partial derivative of m with respect to y is basically given as 1 upon y. And if I check it with the n term, the partial derivative of n with respect to x is going to give me, so over here, if I partially derivative with respect to x, all right, so this is multiplied over here, right? So I forgot to write the 2x term over here. So partial derivative of m with respect to y is basically 2x upon y, and similarly the partial derivative of n with respect to x is given as 2x upon y. So what I can see is that it is an exact differential equation. So if I have an exact differential equation, the solution is very simple. So integration of m dx, keeping y as constant, and then terms of n not having x, right? Terms of n not having x, and then integrate that with respect to y, and that should be equals to constant c. And please note, this should be where y is treated as constant. Okay, so if I perform this following result, then integration of 2x natural log of y times dx plus, and if I look over here, the terms of n which do not contain x is basically 3y square, and that with respect to dy should be equal to some constant c. And if I do this, carry out this integration, this should be equals to x square into natural log of y plus y cube is equal to some constant c. I hope this particular part is clear to all of you. So this is going to be the general solution of such differential equation. All right, so this is going to be the general solution of such differential equation. Okay, all right, is this part clear? Is the solution clear to all of you? Kanish, Hindi sir, Sonic group x square by y, नहीं x square by y नहीं होगा. Sonic, Kanish, okay, I will try to talk in Hindi. Okay, पढ़ लो चाहे कहीं से. सोनिक अपना आंसर एक बार चेक करो. ओके, एक्स स्क्वायर लॉग नेचुरल लॉग वाई प्लस वाई क्यूब इज इक्वल टू सम कांस्टेंट सी, ये होने वाला है, राइट? ओके, आई होप दिस सॉल्यूशन इज क्लियर. इज दिस पार्ट क्लियर टू ऑल ऑफ यू? क्या ये सबको समझ में आता है? क्या ये चीज सबको समझ में आता है? एक बार हाँ या ना बता दो. इज दिस पार्ट क्लियर? Is this solution clear to all of you? Is the solution clear? Great. So if this part is clear, let's now discuss about some equation which can be reduced to the exact form of differential equation, okay? Or equation reducible to exact form of differential equation. So let us discuss about that particular thing. So equations reducible to exact form. Okay, so equation reducible to the exact form. Okay, so equation which can be reduced to or reducible to the exact form. Let's try to discuss about it. Okay, now what we have learned that when we have a differential equation which is basically given the form as m times of dx plus n times of dy is equal to 0. So if I have a differential equation like this, now sometimes it might not be exact. It might not be an exact differential equation. However, this particular differential equation can be reduced to a exact differential equation. How? Reduced to an exact differential equation by multiplying with some suitable multiplication factor or a suitable function, right? So if I multiply both this side by some suitable function. Let us say that particular function is some function f of x comma y. So if I multiply this particular differential equation with some suitable function like f of x comma y, then I might be able to convert that particular form into an exact differential form, right? So this particular multiplicative factor that is multiplied to the non-exact differential equation is known as what is known as the integrating factor. Okay, so अगर आपने लीनियर डिफरेंशियल इक्वेशन वाला लेक्चर फॉलो किया होगा तो वहां पे मैंने इंटीग्रेटिंग फैक्टर के बारे में डिस्कस किया, राइट? सो इफ यू रिकॉल दैट पर्टिकुलर लेक्चर, the differential equation that was present was not exactly differentiable, right? However, by multiplying with one function that was e to the power integration of p dx, that particular function, the following form of differential form of equation was easily integrated or was easily found to the solution, right? So that particular multiplication was something what we called as integrating factor, which is very similar to this over here. Alright, so this is something called as the integrating factor, right? So please try to learn this particular thing, right? But however, how will I know that which particular function should I multiply in order to get to the exact differential form? So this actually comes from multiple practice, and for that one needs to have a suitable practice on the differential equation. However, there are certain identities that can help you to inspect and try to find out that how I can reduce that to a exact differential form, right? So there are certain identities that you may try to remember. Okay, so I'm writing this following identities over here. So if you have following identity like x dy plus y dx, then this can be expressed as derivative of x into y. Similarly, if I have an identity x dx plus y dy, then this can also be given as half times of derivative of x square plus y square. Alright, so please note that there are two forms of x dy, sorry, this x dy plus y dx, however, this is x dx plus y dy, okay? So please note this expression carefully so that you don't actually make any mistakes. Now, the third form identity can be given as, if I have x dy minus y dx and that divided upon x square, that can be given as derivative of y upon x. That can be given as derivative of y upon x. Similarly, in the fourth part, if I have if I have y dx minus x dy whole divided by y square, that can be given as derivative of x upon y. Okay, x upon y, right? Now instead of y square or x square, if I just replace that and I have such expression like y dx minus x dy upon x into y, that can be given as derivative of natural log of x upon y. And similarly over here, if I have x dy minus y dx whole divided by x into y, that can be given as derivative of natural log of y upon x. Alright, so please note carefully these particular identities so that we can apply this to the questions. Okay, similarly there are following more entities as, so if I have x dy minus y dx upon x square plus y square, this can be simply given as derivative of tan inverse of so I should have y upon x. All right, and another form can be given something like this, that is, if I have y dx minus x dy upon x square plus y square, then this can be given as derivative of tan inverse of x upon y, derivative of tan inverse of x upon y. I hope these results are clear to all of you. Please quickly note down this particular result so that we can discuss about the questions. Okay, so why you can apply this particular ideas to basically get to the final form of the solutions. Okay, and I will let you know that how by applying these particular forms, how you can get to the answers really quick. Okay. Alright, so there are certain more forms, however, they are not very useful. However, you might not be able to see them in the question more often. However, they can be easily be incorporated into questions by by certain practices. Okay, so still I will let them know as a form of identities over here. So if I have dx upon dy upon x plus y, then this can be given as derivative of natural log of x plus y. All right. And another form can be given as so if I have dxy plus y dx upon x into y, this can be given as derivative of natural log of x into y. Okay, I hope these results are clear, right? Similarly, the last two forms that I feel are also quite useful, that is, if I have x to the power m into y to the power n, okay, x to the power m into y to the power m, that can be given as x to the power m minus 1 into y to the power n minus 1 m dy, sorry, my dx plus nx dy, okay, nx dy. All right, so please note this particular expression carefully so that you can apply them in the question as and when needed, right? And the last identities among this, the last identities can also be given as, so derivative of some function of f of x comma y to the power of 1 minus n whole divided by 1 minus n is simply the derivative of the function f of x comma y divided by the same function whole raised to the power n. Alright, so this is the following identities that you can remember in order to solve the question really quick. Okay, so I will try to explain this particular idea of using these identities with respect to the following example problems. Okay, please copy this question so that you can have an idea. दिल का फंच सर हिंदी में समझा दी ज्यादा अच्छा से समझ आएगा. See, connects. I can try to explain in Hindi, but there are certain more people also, right? So there are certain more people who do not understand Hindi as well, right? So I have to incorporate those people as well, right, in my lectures. Okay. So these lectures are not only for one particular set of people who know Hindi. However, certain people who do not know Hindi, these lectures can also help them people as well, right? So I have to look into that too, right? Okay. But still I will try my best. Okay. अगर कोई particular part आपको समझ में नहीं आता है, so you can let me know so that I can repeat that in Hindi as well. Okay. But since I'm writing all this thing in English, so I will be trying to repeat that in English only. Okay. Because once you clear your IIT examinations, once you go and take an admission into NIT or IIT, the means of learning is only in English. Okay. So it's better that if you try to understand English by this particular time, so that when you go to university, you don't have actually have problems. Okay. Because in university, none of the professors will be explaining the things in Hindi. Okay. So I think it will be a better practice so that you can incorporate Hindi and to English right now only. Okay. If you are not able to learn English, please learn it. Okay. Because in IIT, all the teachings will be in English only. So even if you clear JEE Mains or JEE Advanced, getting an admission into IIT then won't be that much fruitful. Okay. So please note that particular thing. Okay. But still, I will try to help my best. Okay. To get you understand those things wherever you have any questions. Okay. All right. So I hope this particular thing is clear to all of you. Is this part clear? Is this part clear to all of you? All right. So let's try to see that how we can solve this particular problem. How we can solve this particular problem using this idea of integrating factor. So if I take this particular differential equation, if I take this differential equation, I can still use the idea of the exact differential equation of those identities to club it into the form of the exact differential form, right? How I can do that? It is very simple. So if I simplify the expression slightly or modify the expression, what I can do, I can write this expression as x square dx plus y square dy, and I can write the remaining expression, that is negative times of a will be taken out as common, and that will be y times of dx plus x times of dy, right? And that is basically equals to 0, right? Now if I try to club this particular expression, so if you try to look into this carefully, now if I try to club this particular expression, I can write this expression and club it together by using the identities that we learned. I can club this particular part and I can write it as derivative of x cube plus y cube. I can write this as derivative of x cube plus y cube and whole divided by 3 and whole divided by 3. So when I take the derivative, then this will be the following result, right? And the remaining result minus a times of, now this particular result, that is y dx plus x dy, if I recall from the identity, it can be written as derivative of x into y, and that is equals to 0, right? Now this can be easily integrated. Now this particular form can be easily integrated, and the following result after integration can be given as x cube plus y cube whole divided by 3 minus a times of x into y is equal to some constant c. So if you now recall, the result that we obtained by the idea of the solution of exact differential equation is the very same that we got using this particular exact differential representation. Okay, so I hope learning the both the methods of solving this differential equation is going to be really helpful to all of you. All right, so with this idea and understanding, I hope this give you a lot of confidence to understand about the discussion of this exact differential form of equation. Okay, so I hope this is clear to all of you. Now you can check, this is the answer that we obtained by this general solution approach, and this is the answer that we obtained using the derivative approach, right? Or the reducing to the exact differential approach. I hope this solution is clear to all of you. All right, this solution is clear. Any questions? If you have any question, please let me know. If you have any question, please let me know. All right, so if you don't have any question, then I would request all of you to please try to solve this particular differential equation again by the same approach, by converting into the exact differential identities. Okay, so again this question can also be done by reducing to the exact differential identities or by clubbing the derivative terms, and you can also solve this problem or get to the solution of this differential equation as well. Okay, so I will be hoping that you will be able to solve this by the use of the following identities. Okay, is this part clear? Is this part clear to all of you? So the approach is very simple. What I'm trying to do is that I'm trying to club all the differentiable term into one particular term so that I can easily differentiate that and try to get to the differential form, right? Or something, or what is called as the exact differential identities. Okay, or that I can reduce to the exact differential identities. All right, I hope this idea is clear to all of you. I hope the idea is clear to all of you. If you still have any question, you can always let me know in the live chat. Okay, so we can discuss about those problems. All right, so if you don't have any problems, then I can give you some problems to practice as well, right? So please take some homo problems. So I'm writing some of the problems for practice. Okay, so please try to practice these following problems. Okay, so please try to practice the following problems. Try to solve this following problem: y plus sine of x into cos square x into y whole divided by cos square x into y dx plus x upon cos square x into y plus sine of y whole multiplied with dy is equal to 0. So please try to solve this differential equation. And one more problem I would like to give to all of you is that please try to solve this particular form of the differential equation, that is x plus y dy upon dx whole divided by y minus x times of dy upon dx is equals to x square plus 2y square plus y to the power 4 and whole divided by x square. Okay, so these are the two problems. You can try to practice them as a homework problems. Okay, so please try to solve these two problems and try to get back to the solutions and let me know the solution of these problems in the comment section. Okay, so with this I would like to conclude the discussion on the exact differential equation. Okay, so I hope this idea is clear to all of you. I hope this idea or the discussion is clear to all of you, right? Alright, so please try to solve these two problems and try to get to the solutions so that we can discuss about the previous year question. Okay, so with this I would like to end the class over here and thank you for your attention and hope to see you soon in our next class where we will discuss about the JEE Advanced and JEE Mains previous year questions. Okay, so with this I wish you all the best and keep learning. And also if you need this particular platform, please subscribe the channel and share these videos among your friends, your relatives as well as your juniors. Okay, and also like the video as well as hit the bell icon so that whenever we are live on this particular platform, you get a direct notification and you can attend these lectures live at your comfort of your home. Alright, so with this, I conclude the session. Thank you.